Toot, toot. And talking. And hello. How are you doing, Mama?
I'm doing all right.
Good.
There we go.
Alright. We did Sudoku yesterday, so there will be a lot of stuff happening in between. Just look like it clipped a little bit. But, error. We just did Sudoku yesterday, so we probably haven't done a lot, in between. I haven't done a lot in between.
All I've done is work.
Yeah. So, let's go ahead and get started. Just a teensy bit. There we go. Alright. So, Sudoku, and record, and Between the Skyscrapers by Klausku. Hope I said that correctly. Normal Sudoku rules apply. Cells along a line between two circles must have values between those in the circles. A digit in a circle is a skyscraper clue for its row from the left and for its column from the top. So, assuming each digit was a building of its size, the number of buildings that can be seen from the left of the row or the top of the column is given by the clue. Taller buildings obscure smaller ones. The inequality symbol points to the lower of the two digits. Okay. So, if I'm reading this correctly, imagine that this was a 2. And that means from the left side, only 2 digits can be seen, and from the top, only 2 digits can be seen. I'm reading that correctly. Does that sound right? So like, if this was a 2, you could have 8 and then 9, and then from the top,
No, I
it
think
would
it's
see
what's
the 8.
below it.
And from the left of the row, or the top of the column.
Right, that's where you look at it from.
Maybe. Alright, so let's see how this goes.
Oh. Well, yeah, because it's from its row or column.
Yeah. So, like, if this was a 4...
I guess it would be above it, yeah.
Yeah, so,
Just pretend that's on the outside, basically.
Yeah. So whether it's 4 from the top and 4 from the left, or 4 going right and down. That is the thing I am unsure about. I'm not even really certain where to start. We just know that 5 ends up in here. Okay, well... Alright, well, let's just imagine these two for a moment. Is it possible for either of them to be a 1? Well, the answer to that question is no, because it's is a skyscraper clue for its row from the left and for its column from the top. From the left of the row or top of the column. Yeah, I'm pretty sure that it's as if we were looking from the top. So, like, if this was a 4, it would be the 4 from up here.
Yeah.
In which case, neither of these could be a 1. Because if they were, from the top, this would be seen, and so would the 9 after it. Same from this direction. So we know the 1's off. So now, what can this digit be? Well, it's on a between line, so it's not 1 or 9. And now that we've removed 2...
Neither one of those circles can be a 9 either.
Right. Because it would immediately block the vision. So that removes an 8 as well from the between line.
Neither circle can be an 8.
Which takes off 7. I believe 7 comes off, because the most that can be seen after a 7 is 8 and 9, which would be a total of 3. So 6 gets removed. 6, 7, 8, 9. So, how about a 5? 5, 6, 7, 8, 9. Oh, and I guess one thing that disambiguates the rules as we were sort of discussing it at the start is this circle down in the bottom right corner. Because if it was from this circle, it doesn't see anything. And we can't put a 0 in the grid. So then, okay, this one has a similar restriction. It can be 1 or 2, but it cannot be 9, 8, or 7. Well, wait, hold on. Yeah, it couldn't be 7, because that would be 1, 2, 3, and this was already 7, and then 8 and 9 would make a total of 5.
Right.
A 6 would be 1, 2, 3, 7, 8, 9, which does allow for 6 from both directions. So the most that this can be is a 6. And I guess considering the rest of these, none of which can be a 5, none of them can be a 9. The only circle that can be a 9 is this one in the bottom right corner, because that would allow 9 from both directions, just it being in order. Although, it couldn't be 9 because of its position in the grid. Because if it was a 9, then the digits have to be in order, but then you have 7 and 8 here, and 7 and 8 here, because it has to be in order from this direction as well. So this isn't a 9 either. I don't think it can be an 8 for a similar reason, because that means that the digits are in order, except you put a 9 here. Because this digit couldn't be seen, because it's the last digit. And there would have to be a 9 before it. So that 9 would have to go here, and it would have to be in both positions. So you've got that problem taken care of. And I think 7 is also equally problematic, because you have to see at least 6 digits. So the 9 has to be at the closest one of those two. But because it's from both directions, the 7 wouldn't be allowed. Does that sound reasonable?
Yes. In box 5, 7 and 8 don't work. Because if it was 7 coming from above, 1, 2, 3, 7, 8, 9.
Mm-hmm.
And of course, anything larger doesn't work.
Yeah.
And the one in box 8, 1, 2, 3, 7, 8, 9, 7 and 8 don't work.
If this was an 8, then from the top, it would go 1, 2, 3, 4, 5, 6, 7, 8, 9, in some order. But if this was an 8, you couldn't put the 9 here, because that would only be 7 digits. If you put the 9 afterwards, then that's fine. But this is an 8 and also applies to this way. So if you, again, put the 9 here, well, that's only 6 digits, so it has to be over here, and then the 9 has to be in the box twice. I think 7 is equally problematic for the same reason, because again, the shortest distance you could see is all of these, which is 7 digits, which puts the 9 at the furthest away here, or at the closest to the top here. But then again, if you put a 9 here, that's only 6, so it has to be over here, and then you have 9s in this box duplicated, so 7 is removed. And then the in-between line is 2 through 5.
Well, and the boxes 8 and 9, one of those has to be a 6, because
Right.
there's a 5 on the between line.
So 4 gets
And
removed.
4 doesn't work, yeah.
Because you have to go at least 1 digit below, so that's 2, 3, 4. Okay, and both of these have a maximum of 6, so that's 2, 3, 4, and 5. And, well, the largest digit would have to be a 5.
Mm-hmm.
And since neither one could be a 5, we're going to have a 6 as one of the possibilities. And so then the other one has to be a minimum of at least 2, so we get 3 and 4 removed. If this was an 8, you have a 9 here, but you can also have the 9 here, and those don't overlap. 7, you have the 9s like this. And that's, well, you couldn't put a 9 here, that's not allowed, but you could still put the 9 afterwards, and then they don't have to be in the same box. Although I guess if this was 7 or 8, the 9 is fixed. Which I guess if this is an 8, then that's 7. And then you can't put the 9 here or here, so that would be that. And since that's 6 and 7, as the most digits possible to be seen, this can't be an 8. And I guess also just the fact that it is an 8, be 6 possible digits here, and then only 1 afterwards. And a 7 would again be 6, and you could have the 9 afterwards for... although, where would the 8 go? Because you can't put the 8 on the between line or down here after the 9. So the 8 would have to go above it. So this can't be a 7, actually. And now these are both max 6. 2, 3, 4 is our requirement there.
Right.
And these are both max 6.
Sorry.
Keep missing the 3. Go ahead.
There's a 2, 3, 4, 5. Okay, yeah, what I was... in box 1, neither circle can be a 2, because if it's a 2, well, the 3 or 4 is before it. So it's going to have to be whatever that is, and then a 9 would have to come after it. But then going to the left, it would have to be 2, 9.
Right.
In either case. If that one was a 2, that would have to be 9, and so they can't be 2s.
So then this is a 4, and we take out 4, 3, and 5. Now, well, I was going to say that the 9... No, the thing that's important is one of these is going to be a 5, but it's the start of the column. So that would be 5, 6, 7, 8, 9. But they don't have to be directly in order.
Right.
Because you can have digits in between that space them out, as long as they're smaller than everything before.
Well, at least the one before it.
Right. Although I guess since it's 5 through 9, it's the 1, 2, 3, and 4 that are interspersed in between. But then what could this one be? It's clearly not the 7, 8, or 9, or 5, or 3, or 4. Because this could only be 1, 2, or 6.
Right.
Following that, 2, 4, 5, 6, 7, 8. Okay. So 4, 3, and 5 are removed from the box. It cannot be 8 or 9 yet.
Well, if it was 3, 6, 9 would be fine. But it wouldn't work for the 5.
Right. And but a 1 or a 2 here, it spaces the 3 out.
Right.
But the 5 could be 1, 2, 6, or 7.
Right.
Which gives us some more space. So I'm going to remove that. This we know has to be 1, 2, or 6.
Right. Yeah, in fact, if it's 6, then either the one to the right or the one below it is the 9, depending on which is the 3.
Mm-hmm. Although even then, you could put anything smaller than 6 after the 6 and it still be spaced out.
Right.
which
That's true.
I think would just be 1 or 2, but still. Because, like, what's left over in the box? 3, 4, 5. And if we look going top down, the 3 is not going to be seen past the 4. So we would have a
Right.
4, and then
it wouldn't be able to be 9 yet.
Yeah. So in both directions, the 4 or the 5, it couldn't be a 9. Because if we imagine that this was the 3 and this was the 5, then...
Right, the 9 would only make it 3 for the 5, and
right,
then
you could do 8.
4, 3, 9 wouldn't work because that would only be 2.
But one of these is going to have to be the 9.
Yeah.
And from the 5 direction, it can't be.
Right. And from the 3 direction,
it has to be.
So that center digit has to be a 6.
So this one has to be 6. This has to be 1. I'll remove the coloring for a moment.
Ah. The 1, 2 in box 1 cannot be 1 because 9 cannot be the first digit.
Oh, right. Because we know that this digit is going to be seen.
Right.
Guaranteed. So that gives us a 2 in here. And now the 2 can't be seen.
Well, and the 2 can't have a 1 at the beginning. Well, it could be if it's 1, 9.
Right. It just depends on where the 9 is.
Right. But neither one of those corners can be 7. Because one of them is going to be set the 1, and because the 1 has to be followed by the 9. So if
well,
it's
you could
7,
still put 9. This could be 1, 9. Because if this is a 7, you can put a 1 here.
Right.
And then you can put your 9 over here. You could still put the 9 all the way over here. You just can't put it here, because the 8 would have to be after the 9. And then an 8 would be fine in those positions too, because, I mean, the only thing that's seen after an 8 is a 9, so an 8's not a problem at all. As long as it doesn't go 7, 8. This is the only problem. If we put an 8 in one of these corners, we found the 3. Now the 5 would go 4, 5, 8, 9. So the 5 can't have the 8. That would have to be the 3. But the 5 can have the 7 still. So this can still be a 7-8 pair. The 1's not guaranteed in the corner. Because it would go 4, 5, 7, 8, 9. Oh, this ended up being a 6 because 1 goes to 6. That's not a 6. And it can't be a 5 because there has to be at least 1 digit gap in between. This can't be a 6 And it can't be a 4, because this can't be a 5. Now 6 is one of these two digits.
Oh. There's a 1 in that box in the circle.
Oh,
So
right.
9
9s
has
have
to
to
be
go
those
in.
two.
And now this is 9. So the most that can be seen from this direction is 4. So this can't be a 5. It's now 3, 5. And we see the 4. We see the 9. We can't see the 3, so this digit has to be seen. It's not a 1. I just need 2 more in here. So this could be a 1.
But it can't be an 8.
Oh,
Coming down.
Right.
That cannot be an 8.
Yeah. Now, the 3 places the 9. Because if I were to place the 9 here, it would go 5, 6, 9, and that's only 3 digits, so it has to go this way. And so this 3 here is done. Can this digit be an 8?
No.
If it is, that's a
That
7,
would be
and
7,
we see.
8, 9, and that would be a 3.
So this one's 8. And now this 2 is essentially done, because nothing can be seen after an 8 except for a 9. So I'm going to mark that as done.
And the 9 is going to have to go in one of those 3 in box 4.
Right. So this 5 sees...
coming down from that 4, or coming down, that can't be a 7 after the 5, because that would be 4, 5, 8, 9, or 4, 5, 7, 8. Oh, yeah, that is 5. Never mind. I was miscounting.
Yeah. Going right, the 5 and the 6 are seen. This digit is always going to be seen regardless of whether this is a 1 or a 7, because it's greater than 6, and if this is a 7, then that's an 8. So we definitely see this one. Somewhere over here, we're going to see the 9. So that's 1, 2, 3, 4. We need to see one more. If this is a 7, it's seen, and then those two would be dark. And then wherever the 9 is, we're done. Well, I guess if this is a 7, then we're done. If this is a 1, this has to be a 7, doesn't it? Because
Right.
if it was an 8...
Yes.
Okay.
Column 4 has a 7-8 pair.
So that's a 6 down here. And then what's left over in these digits? 1, 5, and 6. This digit's greater than this one, so this one's not a 2, that one's not a 9. And it's not particularly helpful, so leave that alone for a moment.
Row 7, the 6 can be placed.
Row 7, not in there, not in there, and not this one. Oh. Neither of these can be 1s now, because that would force another 9 in the first row. So that takes 2 out of these. Don't think a 2 is broken for either of those, though. Oh, a 6.
Oh, well, the 6 that's in column 7 takes the 9 out from box 3 in the
Right.
column.
Can
Actually,
this
what
be
can
a
be
9?
in the first cell of column 7? It can only be a 1 or a 2 because it sees 3, 4, and 5. It can't be 7 because that wouldn't be enough to do 6.
Right. It's 9, 8, 7, 6, 5, 4. 4 would be the largest digit it could be. And you've already said the 3 and 4, so.
No.
Now, I guess more accurately, where in this column can 6 go? Clearly it can't go in those. If this was the 9, then the rest of the digits would have to be in order afterwards. It can't be the top of row 7, or rather, it can't be row 7. I think it could be row 9.
What are we looking for?
The 9 in this column. It
Oh, right.
has to be at least one of these 4 digits, and it's not that one.
Well, and it can't be digit 6. Oh, yeah, it could be because it could be 1, 2, 3, or 1, whatever, 4, 5. The first 3 you're seeing the 5, and then
Yeah.
7 or 8 before the 9.
In this row, if this was 9, this would have to be 7, 8, 9. You can have the 9 after the 6 and be just fine. So this one, well, clearly this isn't 9 because of the 6. The 9 has to be in this group. If this was 9, then you can go 1, 2, 3, 4, 6, 9. And it can go 1, 2, 3. 1, 3, 4. So that's not a problem. And if this was 9... Oh, where's the 9 in this column? It clearly has to be at least here. And it can't be in either of those positions. Well, if the 9 was here, that would break the row in for it would break the 6 in row 8. So this has to be the 9. And that forces the 9 here in box 4. So we end up with a 9 in one of those positions.
And in box 5, between the 6 and the 9 has to be seen, so it's a 7 or 8.
7 or 8. And So this has to be in order. So this is 1, 2, 3, and then this is 2, 3, 4. This isn't a 3 because there's already a 3 in the row, and now we have a 1, 2 pair. 1, 2, 3, 4, 8, 9. And then the 9's here, and here replace this 9. I didn't explain that earlier. The 1's here are done. Now the 9 in this box isn't here or here. It can't be a 1 or a 5, and it can't be a 7 or 8. So this is a 9. So this goes 7, 8, 9. Because all of the digits have to be seen. 7, 7, 8. This is a 2, 3, 4. This is a 7, an 8.
Column 5 has a 2, 3, 4 triple.
So this is 5 and 1. 2 there. One, whatever that is, 5, 6, 7, 9. And that is 6 digits. And none of them can be 6. This one can't be 2 or 1. This cannot be 1 or 5 or 3. And this cannot be 4 or 5.
Row 9 has a 2, 3, 4 triple.
This is 5. Out of 5 is 5. Two, 3, 4, 6, 9, and 5 means 1, 7, and 8. So that's not a 1. So this can't be a 2. And it can't be a 3. And that's maximum 5. So that has to be a 4. So that's a 5. This is 2 or 3. It's not a 2. 3, 4 pair means 7, 8.
And 1, 2.
That takes 2 out of this. 3, 4 pair means that's a 2. That's not. 3, 4 pair. 6, 7, and 2? 2, 6, 7, 5, 9. 1, 3, 4, and 8. Okay. This 6 is done from the left. From the top, we know that this digit is seen. This 6 cannot be seen. Theoretically, you could have an 8 above it.
Right.
So we know the 2 is seen. Wherever the 1 is, it cannot be seen. This 6, 1, whatever, 5, 6, 7, 9. It's done from that direction, but from this direction, I don't know.
Oh, column 9, the circle is a 3 or a 4. So cell 2 cannot be a 9.
Right.
Which
So
places
that's
the 9.
9.
That should be all the 9s.
This is now automatically a 2.
2, yeah.
Well, 9, 2, 3, 4, and 5. It can't be
That can't be a
a
1.
1, because that digit is in between those. But now, this being 6, 7, or 8 isn't a problem, because we don't know what these are. But as long as this is bigger than both of those,
Right.
so,
Well, actually, you can place the 6 in that box because there's a 6 in columns 2 and 3. There's a 6 in row 1, and 6s have to be in row. I'm not row 1, but whatever.
row 5.
So 6 has to be cell 7 of box 4.
Why did we say 6 had to be there?
I don't know.
Yeah, I think that was incorrect.
Okay.
Because over here,
Oh,
it's one of
because
those two.
oh no, never mind.
So I think I just messed that up. And ignored this one, and it was just like it had to be like that. But we have this here.
Yeah.
Okay, I'm glad I caught that, because that would have been frustrating if that was wrong. And a little frustrating if it was right, too, but... this cannot be an 8. Because if it was, it would be seen by whatever this is, and the 9. So not an 8. This has to be at least 3. So this cannot be an 8, because then it would only be 2. 1 7 pair makes that an 8, and now it doesn't matter. Or no, this is 1, 2, 3. So this has to be a 3. 4 there, 4 there, 3.
Oh, yeah.
4s.
Okay, well, in between the column 9, in between the 5 and the 9, one of those has to be seen. In column 9?
Yeah. And 5, 2, 3, and 9. And this is not 4, 6, or 8. But it's 1, not both. But we do have a 1,
Right.
7 pair. So what's left over? 3?
3.
6 and not 1 or 4. 7. If this was a 7, we would go 1, 2, 3, 8, 9.
The 8 and the 5. Yeah, that's not enough. That can't be a 7.
1, 7 pair. 1, 7. 3, 4 pair. Seem useful. This is 1, 5, and 7 in the column, so this isn't a 7, because also the 1, 7 pair here. This is 6, 8, and 2.
2.
Well, clearly this can't be an 8, so that's a 2.
Why couldn't it be an 8?
Because of the 6 in the row.
Oh, right, 6.
Yeah. But I should have explained that as I said it. So 1, 7 pair takes out the 1 in the middle. And again, this cannot be a 7, because then it would go 2, 7, 8, 9, and that's only 4. 8. And now we see 2, 3, 4, 6, 8, 9.
8, 9.
1, 2, 3, 4, 5, 6. Get all of these digits to see each other. This is a 3, I think. Fixes those. I don't see a 1, 4, a 6, or an 8. Those aren't 1s,
row
these aren't
2.
6s, those are 4s. Row 2.
Look at what can be seen. 5,
5,
6, 8,
6,
9.
8, 9. So we need a 7.
That's got to be a 7.
One. Okay, so this 5, 6, 7, 8, and 9 is 1, 2, 3, 4, 5 digits. And 4, 5, neither of those has to be both of these and the 9 for 5 digits. Because if it was only one of those, that would only be 4. So this is 6, 8. So now this 5 is done. 6.
Well, the 2 is done there in that box. 6, 9,
8,
and then
9,
8, 9.
6, 9. Yep. 6, 3, 4, 5, 7, 8, 9 is good there. 2, 3. Whatever that is. If it's a 4, it'll see the 5. If it's a 7, it won't. We'll definitely see this digit. Well, I guess if this is a 7, you can put an 8 here. So you won't necessarily see that digit. So 2, 3.
Well, let's see, if
9.
it's 4, it would be 2, 3, 4, 5, 8, 9, which would be 6. If it was the 7, it would be 2, 3, 7, 8, 9, which is only 5.
So
it has to be a 4. If that's a 7, it can only see 5.
And it would be one of those two. But if this was a 7, 1, 2, 3, 8, and 9, yeah. So, cool. And this one is done. That was definitely daunting. Trying to figure out like just where to start thinking at the beginning. But once we started like narrowing things down, looking at the circles and their possibilities, like it the scariness kind of went away, at least for me. 'Cause I don't know, I thought that the puzzle was a bit intimidating to start out. And I wasn't certain how the logic of the skyscraper stuff would narrow things down. But yeah, eventually that was a good puzzle. I particularly like the phrasing the way I said that. But it was a good puzzle, and eventually I got through it. We got through it, not just me. Yeah. All right. Then, crevices by celery. Normal Sudoku rules apply. Each segment of a line within a different 3x3 box must sum to the same value. If a line re-enters the same box, it must also sum to the value for that line. For example, row 5, column 7 plus row 5, column 8 is equal to row 6, column 6, and row 7, column 7 plus row 8, column 7. Different lines may have different sums. Row 6, column 6 is here, and it's referring to each of these segments on the line have to have the same sum. So this sums to that, sums to that.
And going from box 1 down to box 4, there's a 1 that equals 3.
Yep, so that's 6, 7, 8, or 9. Those 3 digits are a minimum of 6 as they are summed together. This group of 5 is minimum 15. So that's 6, 7, 8, 9 there as well.
And the line that goes from box 5, there's a single digit that sums to 3 also.
6, 7, 8, 9. And in box 9, we've got a group of 3 that has a single in box 6.
I think that's all the trios.
Yeah. And this group of 4 is 10 minimum, because 1, 2, 3, and 4 is 10. But there's 2 over here, which is the minimum, but not particularly useful. There's so many things that 2 digits can sum to. All right. Well, this digit, let's call it red, has to be in this box. It can't be on its own line, because it cannot sum with more digits to equal itself, and it cannot see itself by Sudoku. So red ends up being over here. So where is it in this box? Well, it has to be right here. Which means it's going to be on one of these 2 lines. Which means that this digit cannot be red. Because if it was red, if we imagine it was red, then it can't be on its own line, and then it can't see itself by Sudoku. So this digit is able to see all of those, so we end up with this digit being blue. And now we know that neither of these are red, but we don't know that they're not blue. Because it doesn't have as useful information for determining where it could be.
Ah.
What were you thinking?
Uh, One, two, three. Well, no, I was thinking, oh, well, where does the last of the 6, 7, 8, 9 go in row 3?
Yeah.
But it could go on that line.
Yeah. Because
Unless it's 9.
Right.
Because you can't do 19 in 2.
Correct. You can't do 18 in 2 either, so you don't have 8 or 9 on here. So we know that 8 and 9 are in this group. But you can do 1, 2, 3, and 4, and 7, because 1 through 4 is 10, and 7 is...
Right.
7 more is 17, and 8 and 9 are 17. I have a feeling this ends up being a set puzzle. So if we take a look at this row, probably this box, this column, I want to do this box. And I want to do this column. What if I do these two boxes as well? Alright, and then make those red. If I just leave it at this for the moment, then the red sets are two groups of 1 through 9, and the blue sets are two groups of 1 through 9. And so any digits that are in both sets can be removed without changing the equality of the sets. Because we just removed the same parts from both groups. If we look at the sums of the groups, the fact that red has the same sum as blue because they're the exact same digits, we can see that this group sums to that digit. So while we're not removing the same digits, if we remove these, they sum to the same as this one, and so they can be removed, and we can say that red and blue still sum to the same value. We just took out the same amount of value from both groups. And we can do the same thing here and here, because this was in the red group, and its sum was removed, and it's the exact same value as the sum of this group from blue, and red and blue still sum the same. Okay. There's a part of me that wants to do something weird. But maybe I do it anyway. I'm going to highlight this in green. And we're going to say that blue and green are in the same group. So now red is equal, or excuse me. So if I add green to my blue group, then red is equal to blue and green minus 90. Because green sums to equal 90. Now, these digits are in the same group, or are in opposite groups, so it can be removed, and the sums are still the same. It is still, red is still 90 less than blue and green together. And then if I take this out of red, then this can come out of green. Is it still true that blue and green are still 90 more than red?
I have no idea.
Okay, this is where Sudoku Notepad comes into play. So red plus 90 is equal to blue plus green. Now, whenever I've taken digits away, they've come from red and green, and they've always equaled the same amount. So it would be red minus x plus 90 is equal to blue plus green minus x. But that x is the same, so it cancels out. So yeah, so in this instance, red plus 90 is still equal to blue plus green. Alright, if I add this to red and green, then I can take this out of red and that out of green. And so these two digits are 90 less than that group, and this doubly counted. If I add all of this back to red, then I've added 45 to red, so this 90 becomes 45. I can take out all of the green and red from those, and that gets rid of the double counting. And now I can convert this green to blue. We get red plus 45 is equal to blue. And I feel like I've just done a lot of maneuvering without a lot of usefulness. Because another way I could have gone about the coloring here is, let's say all of this is red, and this is blue, and this is blue. Then I can cancel out that. I can cancel out those. Wait, hold on. Never mind. It doesn't matter. Hmm. I don't know. That didn't feel useful. Felt very complicated.
Yeah.
I still like the idea, but it just isn't like enough. It's like I could say,
All right. In column 7,
yeah,
there are only 2 possibilities for a 9. Because the 9 can't
right.
go on the blue in.
It can't, like you
So,
were saying, it can't go up here,
right.
and it can't go on either of these because this is a
Because they
singular,
sum to a single. And the
and it
same with
can't go.
the for the same reason. So that
So,
can't be 9. And 1 has to be on one of those 3 in box 9 that goes to the 6, 7, or 8.
right.
There, I feel like I saw something.
Yeah. Is there anything else that has that same sort of property? We can't
Column
put
2,
nines.
column 3.
Can't go here or here. It can go there. It can't go there, and it.
It could
Uh,
it could go
9
there.
and 6 is 15.
Okay, so that wasn't as helpful.
Yeah. Oh, that was the simple version of what I did before, where I did so much logic to get to this. All you have to do is say, this row is red, that box is blue. If you take out the blue from the blue line here, it's the same as the red here. Add this column, and now blue is 45 more than red, and you cancel out the digit that's in both groups, and that one, and red is still 45 less than blue. Yeah, the logic that I did is just a bunch of wackiness. If I add these two digits to both red and blue, then I can take this out of red, or no, I don't, yeah, I want it out of red, and that out of blue. That doesn't seem useful. But it's 45 more than red. Blue is 45 more than red. So, okay. Blue is equal to red plus 45. Blue, no. Red max is equal to, well, 17 minus a 1, 2 is 14 plus a 9 and a 2. Yeah, I think looking at red, to maximize it, I put the minimum possible value in here as a 1, and these as 6, 7, and 8. So it would be 45 minus 22, which is 23, which I think is the same as what I got here. That says 25. 45 minus 6 minus 7 minus 8 minus 1. I think I did something weird in there. So red's max is 23. So blue has a minimum of 68, right?
Mm-hmm.
So what is blue's max? Well, up
Well,
here would be 30.
if red max is 23, then wouldn't blue max be 68? Since blue is red plus 45?
That's true. So what is blue's min? I guess I want to consider blue's max. Or maybe I should say red max plus 45 is 68. What is blue's theoretical maximum? No, I should be considering minimums. Because yeah, that would be the blue maximum. And I guess if we consider red's min, then that would be 25. No, 15. So blue's min is 60. If we consider the digits that can be placed in there, that would be 65, because you can do 30 here and another 35 over here. Yeah. So if we consider the top corner of box 3 that's highlighted in blue, the maximum I can put in there is 30. And if I consider column 3, 5 digits maximized is 35. Because that would be 6 through 9, which is already 30, plus another 5 for 35, and 30 and 35 is 65. So blue, or rather red, cannot be 23, its maximum is 20. But 5 degrees of freedom is still too many degrees of freedom, I think.
Yeah. I was looking at box 9.
Yeah.
Which of course also leads to that 6, 7, or 8. If it can't be that, okay, where you just put that 5, 6, 7, 8, 9
Yeah.
cannot be. It can only be 7, 8, or 9, because if the 6, 7, 8 in box 6 is a 6, then the diagonal in box 9 is 1, 2, 3.
Yeah.
Which
And you've got
means
4 and
the
5.
down is 4, 5, so it would be 9. If it's 7, then that's 1, 2, 4, which leaves 3, 5, or 3, 6, which is 8 or 9.
Another way of thinking about it is that these 5 have to be a minimum of 15.
Right.
And that means this would have to be a minimum of 7. Because the only way to get 15 with a 5 is a 10, and a 6 would be a 9, and that can't be a 9.
Right.
Yeah, that was definitely... I mean, it's the same logic as this right here, with those two. Just disconnected.
Well, then, so doesn't the last of the blue in box 9 there, the one that's by itself that goes up to the 2 in box 6, the one that's in box 9, wouldn't that have to be 6, 7, 8, 9?
I don't think so.
Because the largest we can use in, let's see.
Because these can go up to 17, so I could make this
Right.
a 5.
Well, that's true.
And this be, because you can do 1, 2, 3, 4,
It could also be a 4.
7. I don't know.
Because
I
if
need a
it's
7
8 with
over
1,
here.
2, 5, and the 9 is 3, 6, that leaves a 4 left over.
Yeah.
Okay, never mind.
I don't know. Oh, this is a similar thing going on, where
Yes, it
these have to
is.
be
At
minimum
least
15.
15.
So we get a 6, 7, 8, 9 here. Now, these can be 18, because these could be the same. They could both be 9.
Right.
Okay, what about this group and this? This is minimum 15. If we consider this extra one, then now it's minimum 16, and that's the sum of these two.
Right.
So I can't put a 6 in those?
I don't think so. Because
Because that would be
7, 9, or
6.
8, 8.
And we know that these are different. Excuse me. This one's red, this one's blue. We know that these are different because we know that this has to be in one of those, and it has to be over here, and that this sees all three of those. So they're not 8, 8. That's not a possibility. So if this is 16, then it's 7, 9. Or excuse me, if these are 16 together, they're 7, 9.
Right.
Or it's 8, 9. For 17, which makes this a 1 or a 2.
Yeah.
But with that, knowing that it's 16 or 17 total, this is either 15 or 16, which means the largest possible digit is a 6. Because we know that these two are different.
Right.
So their maximum sum is 8, 9. Which is 17. This is minimum 1, which means the maximum for these is 16. So red is this digit. Because we said that red had to be one of
Right.
these three. Red can't be a 6, because the sum of these two is all of these digits. And since we know that they're different, that's maximum 17. Or excuse me, minimum 16. You can't put a 6 on there. Remove this. This is now maximum 16. And so you can't put a 7 on it, because it has to be at least 1, 2, 3, 4. Plus 7 is 17, which is too many. Because then you have to add that for 18, and you can't get 18 from those two if they're different. Okay, so this is red. And so now red is one of those two. So blue ends up having to be one of these, because blue can't be any of those.
Right.
These are just min 10. Well, it got us farther.
Yeah.
The minimum of 5 digits is 15. These can't both be 7, therefore they're 8, 9. Because 5 digits has to be 15, and 2 sevens
Right.
are 14. So it's too little. So now this cannot be an 8-9 pair. So its max is now 16. Which means I can't put a 7 on here.
They're 1, 2, 3, 4, 5, or 1, 2, 3, 4, 6.
Right. A 7 makes us a 9. A 9 makes us an 8. And an 8 makes it a 9. Uh, where can I put 8 in this column? It's clearly not there. Or there. So either this is an 8-9 pair, or this is a 9. But I can't put 8 here. Wait, hold on. I can't put 8 here, because this can't be a 9. I can't put 8 on here, because it would have to pair with a 1. But because this can't be a 9, this has to have a 1. So 8 can't go on here.
Right.
8 can't go on these, so 8 has to go in this group, so this isn't an 8. So now this is 1, 2, 3, or 4. If this was a 7, that would be a
Right.
6,
That
so
can
this
only
can't
be
be a
8 or
7.
9 now. If it's a 6, it's a 9, and if it's 7, it's 8 or 9. So yeah.
And that means 15 or 16 is the possibilities. So this is max 6, but it can't be 1 or 2. And this has to be 1 through 6. So now where does 7 go in this column? Well, it has to go here. These are 7, 8, 9. This can't be a 9, so this is a 1 or a 2. But the question here, because this is now 15 or 16, is whether or not we have a 5 or a 6. So I have 1, 2, 3, 4. So this is 5, 6, 7, 8, 9. Oh, this is 7, 8, 9. This is 6. Dirt.
Oh, right.
So this has to be 4, 5 for a 9. Which means our 9 is here. Means that's not a 9.
And then in box 9, we've got 1 through 5, so it's 6, 7, 8, 9, and the other 4. So the 5 comes off of the 1,
And 6 has to be one of these two. So we know we have a 6 on here. And because we know we have a 6 on here, and because this was not 17, it had to be 15 or 16. We just learned we have a 6 on here. This is 1, 2, 3, 4, 6. Where 6 is neither of those two. And this is 5, 7, 8, 9.
In the first column.
Right. But this is 16. So this is 7, 9. Where it goes 7, 9. And now this is 16 and a 9. Wait. Yeah, 9. Because this here was minimum 16. So I can't put a 7 here. Because that would make this too small. Yeah, that's fine. So this is an 8 or 9.
Well, the 6 comes off of the possibility for the 8 in box. There. The 6s come off in box 4.
It's whether we have a 5 here or a 5 or a 6 here. Because 17 is all of this. Take 1 away, this is 15 or 16. This is 1, 3, 4, 5, 6, 7. Can't be an 8, can't be a 4. Not a 6, not a 2. Nine, 8. We don't need colors anymore. 9 ends up being one of those. That's not a 9. So where does 9 go in here? It's not on the top, it's not on the bottom, it's not on either of the 8s. So it's a 9 there. And the 9 couldn't be in any of these, which is why it had to be up here. And now it can't be in any of those, so 9 is here, not the top. So 9 is one of those two. Pairs with those two. So 9 isn't... Oh, never mind. Those 3, so 9's in that block. Okay. So this is maximum 5.
Okay, column 3 in box 1, it's going to be either 5 or 6, and 7, 8, 9. Well, it can't be 7, 8. That one's 5 or 6.
If this was a 9, you couldn't do 1, 2, 3 for 15. Because 6, 7, 8, 9, 7 and 9 leaves 6, 8, which is 14. So You can't do 16. You can't do 17 because that requires a 9.
Because that would be 8, 9, right?
So this can't be a 9. It's a 7. Six and 7 is 13. So 4 and 9 aren't allowed, and 7 aren't allowed. So this has to have an 8 on it.
Yeah, but that's
And it's
assuming
either...
that's 13.
Well, that was minimum.
Right. Oh, right.
So, you can't put a 4 on here because it would have to pair with a 9 just to get to 13. And since
Right.
9's not allowed, 8 and 5 is the minimum. So these are the only possible digits. And if you didn't have an 8,
so
it would be
sum's either
11.
6 or 7.
So this is 1, 2, 3, 4. And it has to have 1 and 2. So this is 3, 4, 5, 6.
Yeah.
So 8, 6, 9. 1, 2, 3, 4, and 5. So 5 is out of these two?
Looks like it. Which puts 5 on the right in box 3.
5 is out of those. And 8s aren't very restricted. Only I hadn't gotten distracted with the set stuff. Set didn't go anywhere. Because once you saw this combination down here,
Right.
because it was the same logic as this stuff, just disconnected a little
Which
bit,
led to box 4,
which led to column 3, and then the bottom of column 2.
right.
But sometimes you have to look at the wrong thing first. This is 1 through 6. What are we missing? We know that these sum to 9. No 6, so no 3. That doesn't seem to be restricted to that much. This can't be 1 or 7, because 8 has to have a 1 on it.
Right. Oh,
And we
8 has
know
to have a
this.
1 on it. 8 has to have a 1 on it. So the 1 comes off for down below for the 9.
Right.
But it could still be 1, 2, 6.
Now, we know that this is 16. You can't have a 5 in it. It has to
1,
go
2, 3,
2,
4, 6.
6.
Yeah.
2, 6.
Alright, well the 1, 3, 4 takes the 3, 4 out of there.
And
So
now
it can't
this
be
is a
2, 3,
1.
4. So it's 1, 2, 6.
Making this a 5. Here we go.
3,
That's
4
what was
pair
missing.
in box 1.
8, 3, 4, 3, 4. That makes that a 6. 6s are out. 2, 1, 1, 8. One, 3, 2, 3, 4, 6, 9. 2, 8, 6. 3, 4, 5, 7. That was probably loud, closer to my mic. Sixes up there, so we'll do that. 5, 7, 8 as a triple.
Leave 1, 2, 3, 4.
And we have to have the 4 here, so that's not a 4.
So where does 4 go in row 1?
Oh, because it can't go here because of the 4, 5. Can't go there because it had to be on the 16. It can't go there, so that's a 4, that's a 3. And now this has to be 6, 8, because this is 7 and
Yes,
7.
14, yeah.
8, 9 pair, so 1, 2, 3, and 5, I think. 3 and 6 is out, 3 is out, not a 6. Well, so leave the 4s there. Not 4s, not 3s. 8, 1, 6, 3. That's a 6. This is not 6 or 7. And since this is a 6, it can't be 3s. And
that's a
1
virtual
and 2,
1-2 pair.
That takes that out of there. 3, 4. What is this middle one? Well, it's not 6 or 9. I was kind of hoping that'd be a little bit more restricted. maybe combine with these two or those. 9 from there, 7 and 9 from there. Yeah, it's not very helpful. 1, 2, 4 means this is 6.
Yeah, I saw the 1, 2, 3 in column 7, but you got there before me with the 1, 2, 4 in row 3.
Oh, this being 2 or 3 means this has to have the 1s. The 1's out of there, so this is 1.
Oh, right.
That's not. These are pretty restricted. 1, 6, 8, 9. 1, 2, 6, 8, 9. 6, 7, 9. There's a lot of digits in there still, so probably not
Okay,
where the logic is.
in box 5, the line that sums to 9, the top can't be an 8, so the bottom can't be 1.
Right.
There's no 2 so in the bottom, so there's no 7 on top. There we go.
Wait, why can't this be a 1? That
There
can
was
be an
no
8.
Oh, okay.
Okay, clearly not a 9 because it sums to 9. 2 pairs with 7. 6 in both pairs with 3. I think I messed up earlier and grabbed the wrong pairs of digits.
Okay, yeah, I was just going by what was actually in there.
Yeah. It's good we caught that, though, because that would have been annoying if it was wrong. Which is what? Twice that's happened today? So I need
I
to
don't
be
know.
a lot more careful. 1, 2, 3, 4, but that logic's already been done. This has to be 7, but that logic already exists. Is this correct? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Got a 4, 5 pair. 2 and 7 are together. 3 and 6 in one direction. And that takes the 6 out, and that takes the 1. And well, can that be 1 in this 8? No, that can't be 8. So, oh, right, because the 1, 8 sees that. Guess let's fill in the rest of these digits. So that looks like it can't be 6, 7, 8, or 9. 7, 9, 7, 9, and 1. 1, 6, 9. 6, 8, 9. 1, 8, 9. So there's lots of digits in there, so we gotta go find other logic, probably. I guess, where is 8 in this column? I guess it can be down here. It's not there. That's not it.
Oh.
Oh,
In box 6, the line that sums to 6, the bottom can't be a 1 because the top can't be a 5.
right. And this can't be
And
a 4 because
be a
this can't
4
be a
because
2.
that can't be a 2.
Right, so now we've got our
1,
1,
2
2 going
pair.
across.
Yeah. 3, 4, 5. The 3 has to be on the top row, so that takes the 3's out from the rest of row 4.
And I fixed the stuff in here, so now there's just a 4, 5, and a 1 on the bottom and an 8 on the top.
Okay.
2s have to be paired like these. Oh, this is 2,
Right.
4, so the 2 comes out of there. 1, 3 means that's a 2. Oh, 2's out of there, so that's 6 and 2. So 2's out of there, 6 out of there, which means that's another 3. Those can't be 7s. So 4 and 5. 4, 5 pair here. And now this can't be a 4, 5, so this is 1 and 8, which I think, well, I'm not sure. We'd have to go back and check. But yeah, I might have been the thing I messed up. 5 has to be one of these.
Oh, box 6. 7 adds to 2 for 9.
4, 2, 5, 3, 4, 1, 3, not a 3, not a 3, not a 3, 7, 5, not a 7. 3, 2, 1, 3, 9. 4s are out, that's a 7, that's not. 2, 6 pair doesn't do anything. That's a 3, 8, 6, 7, 9, 7, 8, 9, 8, 4, 2, 3, 5, 2. No, that's 1, that's 3, that's 1, that's 2, that's 6, 4, 3, 5, 3, 4, 5, 4, 4, 5, 4, and 5, and it's solved! And it would have been a lot faster if I hadn't got distracted with trying to do set stuff when
Oh well,
this logic
it
was,
happens.
yeah. That was, I think even if we had been on, yeah, it was definitely challenging. Even if we had found the right path sooner, I'd still think I would have considered this a very hard puzzle. Because I don't know, like it was just very, very nitpicky, in some aspects. Like, I don't know, it's late, so like the mistakes are probably from it being late, but but even without those, I still think that was very difficult, very mathematically intensive puzzle.
Yeah.
Because I mean the fact that
lines.
Say again.
Some lines.
Yeah. Because I mean, like Sudoku, isn't. I mean, it's still technically a mathematics puzzle, but like you wouldn't need to use numbers in Sudoku, like classic Sudoku, and even like some other versions of like variant Sudoku. Although quite a few variant Sudokus seem to apply mathematics, which makes a lot of sense because even classic Sudoku is still a maths puzzle. Like you're doing a lot of set logic and stuff, because it's like even if we used all letters, which in some puzzles we do anyway, like it's still like doing the like set logic to figure out what the end result is supposed to be. But anyway, I guess I don't need this up anymore because that was not useful. I'd forgotten to minimize that a while ago. But man, the stream is, at least on my phone, is super far behind. What does it look like if I click the live button? Probably just me looking down at my phone. But anyway, because I have to look down to see what my phone is showing. Anyway,
Right.
Yeah, I feel like I'm a little bit all over the place trying to talk about the puzzle and then getting distracted by things. But yeah, final thoughts on this puzzle or Between the Skyscrapers, Mama?
Mm, this one was challenging. The Between the Skyscrapers was, in comparison, wasn't nearly as challenging.
Yeah, they're both very good puzzles though.
Oh yeah.
Yeah, definitely enjoyed those. And while I'm thinking about it, I'm gonna go ahead and copy those into the video description so that way people can, if they want, find the puzzles to solve them themselves. But yeah, alright. Then, I don't think there is anything else to do with Sudoku. Stop recording. But yeah, alright. So, we are not streaming, at least not streaming Sudoku on Thursday. So, I might decide to stream anyway. But I would be playing some other random video game. Well, I guess Sudoku's not really a video game. It's more of a pen and pencil puzzle, but solving it through electronically, I think, offers a lot more options for being able to solve, especially fairly difficult puzzles, to make them a lot easier. Other than that, I don't think I have any final announcements for the streaming part. Anything that you want to say before we sign off, Mama?
Bye.
Yep. Alright, thank you for watching. Like, comment, subscribe, YouTube engagement stuffs, and we will see you next time.